What's up? We got the last two types of free response problems that show up consistently. Differential equations that involve separation of variables, and then area volume. Okay, the ones that you probably remember the least are the differential equation separation of variables. So we'll start with the 2018 number 6. And these are questions that are like easy to forget how to do completely. So this is a derivative. And some questions that are common are slope field questions, tangent equations and tangent approximations, and then solving the differential equation through separation of variables. So remember, we could create this slope field by plugging in points into this derivative and plotting the slope. So that's a reminder of slope fields. You want to sketch the solution curve that passes through the point 0, 2 and 1, 0. Sketching the solution is like, what is the y equals equation, or what is the implicit equation that satisfies the slope field? Well, like through this point 0, 2, you can see like this straight line y equals 2 kind of passes through that point 2 and follows the slopes. Versus here at 1, 0, it looks like it's more of like a curve. And that curve looks like it flattens out and then maybe comes back through here. And that's all you would need to do to sketch a solution curve. It's very easy to do. Write an equation for the line tangent to the graph of y equals f of x at equals 1. Use your equation to approximate f of 0.7. Exactly what I asked, what I told you. Like something that shows up consistently is like these tangent line equations. So tangent equation, y minus y1 equals my tangent slope x minus x1. We have this point 1, 0 at x equals 1. They're giving you the x1 and the y1. 1 is the x, y is 0. So all we need is the slope. So this would be dy dx at this point 1 comma 0. So we go up here and we find what dy dx is at 1, 0. 1/3 times 1 times negative 2 squared. So that's 4/3. So there's my equation. Y minus 0 equals 4/3 x minus 1. And then we say use that equation to approximate f of 0.7. So when x is 0.7, what is the y coordinate? So again, since it's a no calculator question, you could literally leave your answer like this. And that's fine. This is acceptable. If you'd like to, you could write this as like negative 0.3. Negative 0.3 is negative 3/10. And then you get negative 4/10, which is the same as negative 2/5. And that's approximately f of 0.7. Great. You know, that's not that many points, A and B. Part C, this is when it's like this question is one of the most highest point givers or takers away on the AP exam. It's like 4 or 5 points. It's like find the solution to this differential equation. Okay, now what we do, how do we find the solution? Now, solution to a differential equation is, what is the equation? What is the y equals equation? We need to like take the antiderivative of this, but the only way we can take the antiderivative of this is through the process of separation of variables. This is when we like move the y's to be with dy and we move dx to be with the x's. So I'm going to divide by y minus 2 squared. I like to write it as 1 over 1 minus 2 squared. I'm going to multiply by dx. And there's dy over here. Now notice I didn't distribute anything. I'm not going to distribute anything because you're not going to be able to take the antiderivative of this if it was distributed. I mean, it would be more difficult. But that's step 1, separating variables. Step 2 is now, okay, I'm ready to take the antiderivative. Well, I'm going to rewrite this as y minus 2 to the negative second and then use the power rule. So it would be y minus 2 to the negative first times negative 1. If there was some coefficient of y, I would multiply by the reciprocal. Over here, I got x squared times a half, so that'd be 1/6 x squared plus c. Now, your goal is to solve for y equals. We need to solve this for y. And you're going to use the initial condition 1, 0. You can choose when to plug in 1, 0. If you ever have things with logs in it, it's probably best to wait to solve for y and then plug in the point. This is fine if we just solve right now. Plug in 1, 0. And then we'll find c, and then we're going to, go ahead and solve for y. So when y is 0, I have negative 1 over negative 2 equals 1/6 plus c. That's 1/2. I'm going to subtract a 6. This is easy enough to do by hand. It's 2/6, which is 1/3. So I get what c is. I'm going to move this over here. I got negative 1 over y minus 2 equals 1/6 x squared plus 1/3. Now, how I'm going to solve for y? Well, I'm going to take the opposite of both sides. I can flip both sides. Now, when I flip both sides, I'm going to put everything on the right side under a 1. And then I'll solve by adding 2. Now, can you do other things to make this look different? Sure. Will we see this answer on the scoring guidelines? No. They're gonna show you how you can maybe multiply the top and bottom by 6 or by -6. And if I multiply the top by -6 and the bottom by -6, I'll get this. And you could also combine this 2 with that if you want to, but this is acceptable. This is a free response, so as long as it's correct, it's correct. Anything else is just making it look nicer. Let me show you the scoring guidelines for 2018. Number 6. See, 2 points, 2 points, 5 points. Okay? 2 points, those are the solutions that we sketched. 2 points, one for the equation of the tangent line, one for the approximation, negative 0.4. But again, you could leave your answer like this. And now 5 points. Ready? Let's talk through the distribution of the points. 1 point for separating our variables correctly. So just doing this first step, 1 point. 1 point for each antiderivative. 1 point for making sure you use the plus c. You don't forget about a plus c when you take an antiderivative. And then 1 point for using 1, 0 and trying to find c. And 1 point for solving for y correctly. And notice what they have, 2 minus 6 over x squared plus 2. 2 minus 6 over x squared plus 2 is the same as this. Okay, it just looks different. If you leave your answer like this is totally fine. All right, so man, 5 points. 5 points, easy 5 points or an easy 0 if you don't know how to start. Next question is 2017, number 4. This is a good question to do first on your homework while we do it in class. Okay, now we have to be ready for differential equations that don't have x's and y's, but have different variables. Like here we have h and t. The same thing applies. You just think of h as being your y and t as being your x. All right, say the internal temperature of a potato is 91 degrees Celsius times t equals 0. They give you that here. H of 0 is 91. Okay. The rest is just filler stuff. At this point, this differential equation, all you need. What shows up frequently? Equations of tangent lines. Write an equation for the tangent line to h at t equals 0. Use this equation to approximate the internal temperature, t equals 3. So your equation of a tangent line, we're used to this. Y minus y1 equals our tangent slope x minus x1. But I'm just going to change this to h's and t's. But that's my y1, that's my h1, that's my x1, that's my t1. So I get h minus 91 equals some slope, t minus 0. Now, All we need is dH dt at 0.91. So what's dH dt at 0.91? It's negative 1/4, 0 minus 27. No, 91 minus 27. Might as well figure out what this is. I know you don't have a calculator, but whatever. That's 4, that's 64. I feel like I can divide 64 by 4, but I can't. It's 32. It's 16. 16 times 4. Yeah, it's 16. So this is just negative 16. Okay, so this is negative 16. It probably is worth it to do the extra little work to get that number, negative 16. Approximate the internal temperature at T equals 3. So we're going to approximate H of 3. So that's going to be negative 16 times 3 plus 91. Leave it like that. Don't waste any time. Okay. I'm just going to do it just for our scoring guidelines. Negative 16 times 3 is 48 plus 91. That's negative 48 plus 91. So 91 minus 48. My cursor's all over the place. Is 43. Okay. Now, this is a tricky one. Everybody messes up on the second derivative. And implicit second derivatives are tricky. Because whenever we take the derivative of dH dt, we're taking the derivative with respect to t, which means when we take the derivative of h, it's going to have a dH dt. Now, it's actually helpful in this question to take this negative 1/4 and distribute it. Okay? Why do I say that? Just so you don't mess up when you're taking the derivative to get d squared h over dt squared. Now watch. D squared h over dt squared equals not negative 1/4. This is a common mistake. Everybody thinks it's just that because it's like, oh, it's like x and I take the derivative of that. No, this is y. Whenever you take the derivative of y, you need like dy dx. Well, we need dh dt. Now, what does that mean? You need to take what dH dt is equal to and plug it in for dH dt. Now, when t equals 3, h is 43. It's bigger than 27. That's important. They gave you that for a reason. When h is around 43, this is positive times a negative times a negative. This is positive. Okay? Now, since the second derivative is positive, is our tangent approximation over or under? Well, if you have a concave up graph and you use a tangent line to approximate, all your points on your tangent line, regardless of like its location relative to the centering of your tangent line, is under. So this approximation 43 is under the actual. Why? D squared h over dt squared is positive. You don't have to say, oh, the formula for h is concave up. A lot of people will make a mistake and they'll say dH dt is concave up. No, that's not true. dH dt is concave up would say like its second derivative is positive, which is like a third derivative. You could talk about the original function h, which you don't have, which we haven't found. But we're not going to do that. We're just going to say a sign of a derivative. The second derivative is positive. Tells me my original function's concave up. The approximation is under. Be simple, underestimate, second derivative is positive. Okay, now, I was going to think that we would solve this differential equation. I'm going to show you how to do it just for fun. But they're throwing this other differential equation at us. They're saying an alternate model is given by g, where dg dt is this. and g of 0 is 91. Find an expression for g. They want you to solve this differential equation, not the original one. So you might be thinking with all these, it's like, oh, I got to solve this. I got to solve this. Actually, no, not in this situation. We got to take dg dt, take the antiderivative of that. Now, how are we going to do that? This is very similar to the last one that we did, where I'm going to divide by g minus 27 to the 2/3, multiply by d. I'm going to keep that negative over there. I like keeping constants where they start out, just because I think it's easier with the antiderivative. I'm going to take the antiderivative right now. I'm going to do the same thing with the original one just to show you how you can, but it's not asked of you. They never asked you to solve this differential equation. Okay, this turns into g minus 27 to the negative 2/3. I'm going to add 1 multiplied by the reciprocal, so that's g minus 27 to the positive 1/3 minus times 3. If there was a reciprocal of, if there was a coefficient of g, I would multiply by the reciprocal because I'm taking the antiderivative. There is none. Over here, I have negative t. Don't forget a plus c. I have the original condition g of 0 is 91. So I can find c now if you wanted to. It's actually probably, I mean, I don't know if it's easy right now to do it or if we should wait. But as long as I don't have like a log, it's okay to find c earlier rather than later. So let's just do it. 91 minus 27 to the 1/3, whatever that is, equals c. I bet you this works out nicely, but I'm not sure. 91 minus 27 is 8, 4, 64. The cubed root of 64 is 4. So this does work out nicely. 4 times 4 is 16. 16 times 4 is 64. So this is 4. 4 times 3 is 12. So C actually is a nice number. It's 12. So that gives me 3 times g minus 27 to the 1/3 equals negative t plus 4. I'm now going to divide everything by 3. So g minus 27 to the 1/3 equals negative t plus 4 over 3. Cube both sides. G minus 27 equals this entire thing cubed. Don't be tricky. Don't cube everything. That doesn't work. Then add 27. G equals negative t plus 4 over 3 cubed plus 27. There you go. Leave it like that. Okay? You'll see there's like probably 5 points, maybe 4 points for this part. Now let's say they asked you to solve this differential equation. I'm just going to show you really quickly. dH dt equals negative 1/4 h minus 27. I would leave the negative 1/4. I would move the h over 27. And this is one I wanted to show you because antiderivative of the left side we haven't seen yet involves a log. This is h minus 27 to the first. If you were to rewrite it, it'd be h minus 27 to the negative first. The power rule for antiderivatives works for every power except for a negative first power. The antiderivative of this, x to the negative first, antiderivative is log absolute x. This is log absolute h minus 27 equals negative 1/4 t plus c. How do you solve this? Don't plug in your initial condition yet, 0.91. Take e to the power of both sides. You can get rid of the absolute value. It'll work out when we find the solution, whether we get a positive or a negative. When you take e to the power of the right side turns into e to the negative 1/4 t plus c, which turns into e to the negative 1/4 t times e to the c. Remember how using exponent properties, x squared plus 3 turns into x squared times x cubed? That's why I write this as e to the negative 1/4 t times e to the c, which turns into then c e to the negative 1/4 t. So I get what h is, c e to the negative 1/4 t plus 27. And then I have my initial condition 0.91. 91 equals c e to the 0 plus 27. So 91 equals c plus 27. C equals 64. So if you were asked to solve for h, it would be 64 e to the negative 1/4 t plus 27. They don't ask you that, though. Let's look at the scoring guidelines. Number 4. 43. 43, you get 1 point for the slope, which is 16, or negative 1/4 times 64, negative 16. You get 1 point for your tangent line. You don't have to put it like they put it. They solve for y. You didn't have to do that. Leave it like this. This is fine. And then 1 point for your approximation. Part B, it's only 1 point. Look, the second derivative is negative 1/4 times dh dt. And there's negative 1/4 times dh dt. Okay? And when they said, hey, h is bigger than 27 for t is greater than 0, which means this has to be positive. They are saying h is concave up. Now they say h is concave up, not dh dt. You can just say the second derivative is positive. It's an underestimate. That's fine. Now, 5 points. Ready? Separating our variables, 1 point. Antiderivatives was worth 1 point because the antiderivative on the right side is easy. Look, they left the negative 1 over here just like I did. They got the negative t plus c. They got 3g minus 27 to the 1/3. They found c was 12, just like I did earlier. They then solved. They didn't keep the fraction. Actually, they did 12 minus t. Why is it 4? Why do I have 4? I made a mistake. 12 is c. Why did I put 4? I was like thinking about dividing. Why did I do that? I was like dividing 12 already by 3. I don't know why I did that. Sorry, guys. I would have gotten 4 out of 5 points if I did that. Okay, so negative t plus 12 over 3. T 12 minus t is the same thing. And then, I forgot even the last part. Based on this model, what is the internal temperature of the potato at t equals 3? G of 3 equals 12, 11, 10, 9 over 3, 3 cubed plus 27. So it's 27 plus 27 with 54. Gosh, read the question. I mean, look at me. I'm just like rushing through this, not even reading the question. My bad, guys. Read the question. I was supposed to solve. Don't do any mental math before you actually do the math, and then make sure you do every single part of the question. I was all focused on getting this answer. But notice they don't have anything about H. All right. 2016, number 4. They've taken a couple of years off from having one of these differential equations. If you're taking the paper version, I almost guarantee there's going to be one this year. They didn't have one last year because it's easy to cheat on these problems, actually. You can pop this up and just Google it, solving differential equations. So people on a digital exam, I wouldn't expect to see this. People on the paper exam, I would expect to see this. All right, now they give you a differential equation. They expect you to fill out a slope field. You only got 6 points. Okay, now how do we do this? We plug in the points into the differential equation. So let's start down here, 0, 0. I'd have 0 squared over 0 minus 1, that's 0. So boom, slope of 0. 2, 0. 0 squared over 2 minus 1, which is 1. But that's 0 because of 0 in the numerator. Let's plug in 0, 1. So x is 0, y is 1. So I have 1 over negative 1. So that's negative 1. 2, 1. I'd have 1 squared over 1. That's just going to be positive 1. 0, 2. I'd have 4 over -1, -4, so steeper. Just make sure you show it that it's steeper. And then 2, 2, I'd have 4 over +1, so that's +4. Okay? Let y equals f of x be the particular solution. Now, they say that, but then they look, write the equation for the line tangent. They don't want you to solve it until part C. A lot of people make the mistake of solving the differential equation before it's asked of you. This is just a tangent equation. Y minus y1 equals m times x minus x1. They give you the point 2, 3. Y minus 3 equals some slope x minus 2. You need the slope at 2, 3. Let's find dy dx at 2, 3. So it's 9 over 1. So it's 9. Use your equation to approximate f of 2.1. So I got f of 2.1 is approximately 9 times 2.1 minus 2 plus 3. Leave it like that. That's fine. It's a no calculator question. This is 0.1 times 9, which is 0.9 plus 3. If you want to, it's easy to get 3. Now let's solve the differential equation. Okay, separate your variables. Divide by y squared, multiply by dx. The x minus 1 stays on the right side in the denominator. Take the antiderivative. This side, I can use the power rule. I get y to the negative first times -1, which is -1 over y. The left side, the antiderivative involves a logarithm, log absolute x minus 1 plus c. Why? Because this is x minus 1 to the negative first. The power rule does not work with the negative first power. We got to remember the antiderivative of x to the negative first is log absolute x. I'm just going to go ahead and solve now because I have a logarithm. It's actually easier to solve. I'm going to take the opposite of both sides. I don't have to worry about making this a minus c, but if you wanted to, you could have. And then I'm going to flip both sides. And you could have flipped both sides first and then put the negative up top, which actually is probably a little bit nicer. So I'm going to do that. So this is a negative. Let's flip both sides. This stays as a positive in the denominator. This stays as a positive, but then the negative goes up here. Initial condition 2, 3. 3 equals -1 over log of 2 minus 1, which is 1 plus c. The log of 1 is 0. 3 equals -1 over c. Multiply by c, divide by 3. C is -1/3. So my solution, though they're not going to have this, I'll show you what they do, is -1 over log absolute x minus 1 minus 1/3. Though this is good for you to know because on a multiple choice question, you usually don't see this answer. You usually need to know that you should multiply the top and bottom by 3. They don't like having fractions in denominators. So I bet you we see um, -3 times 3 log x minus 1 minus 1, or like opposites of all that. Okay, let's see 2016 scoring guidelines. Slope field, 2 points. The zero slopes, the non-zero slopes. Okay, that's nice, easy 2 points. Tangent line and the approximation. 1 for the tangent line, 1 for the approximation, 3.9. You could have left your answer like that if you're not comfortable. 5 points. Oh, look, they didn't even do that. They separated variables, took the antiderivatives, found c, used c, solved for y. They didn't even simplify by multiplying by 3. So this version is actually what they had, though they had the opposites of everything. Hey, it could be easy 9 points if you guys are ready for it. 2015, number 6. Okay. Okay. A lot of times with differential equations, it's like, hey, part of it is to solve. Look at A, look at B, look at C. Write an equation. Find all coordinates of the points of the curve which the tangent line is vertical. Evaluate the second derivative. You don't have to solve this. Thank goodness, because you don't know how to solve this. You wouldn't know how to solve this. It's fantastic. We just have to do these three parts. I need a y minus y1 equals m times x minus x1. I don't even need to approximate something. I have y minus 1 equals some slope x plus 1, plugging in negative 1, 1. I just need to find my slope at negative 1, 1. So that's 1 over 3 minus negative 1. That's 1/4. Great. Boom. I bet you that's 2 points. I mean, there's only part A, part B, part C. Part B. Find the coordinates of all points on the curve in which the tangent line of the curve is vertical. All right, let's remember. Horizontal tangents is when the derivative is 0. If you have horizontal tangents, if you have a fraction, all you need is a 0 in the numerator to get a 0. Vertical tangents occur when there is rise but no run. So that is when your derivative is undefined or when you have a 0 in the denominator. So for a vertical tangent, I need my dy dx to have a 0 in the denominator. So I'm going to set that equal to 0. Now, unfortunately, I have this equation, 3y squared minus x equals 0. It's like, what the heck do I do with that? Well, we got to be ready for this. We can solve for a variable and then use our original equation to then help find us some points. And we got to find coordinates of all the points. So I got x equals 3y squared. I'm going to plug that into the original. Whenever I see x, I put 3y squared. Watch this. This is going to be nice. Y cubed minus 3y cubed equals 2. Negative 2y cubed equals 2. Y cubed equals negative 1. Y, therefore, is negative 1. Negative 1 cubed is negative 1. When y is negative 1, what's x? Negative 1 squared is 1 times 3. 3, negative 1, making sure y is the second and x is the first. That's it. 3, negative 1. That's the only point I have. It's the only y coordinate. And you can use either equation, this equation or that equation, to find the x coordinate. So use the easier one. Use this one. All right, part C. Again, this is a lot of people get tripped up on this. What's the second derivative? Don't take the derivative of this twice. You already have the derivative. You have dy dx and what it's equal to. So dy dx is y over 3y squared minus x. We are ready to take the derivative of this with respect to x. Remember, whenever we're taking the derivative of like a y, we need a dy dx. Whenever we're taking the derivative of like h with respect to 2, we need dh dt. Don't forget this. It's a common mistake. So dy squared over dx squared, d squared y over dx squared equals. This is a quotient. I have to use the quotient rule. So it's the derivative of the top times the bottom minus the derivative of the bottom. So that's going to be 6y dy dx minus 1 times the top, all over the bottom squared. Now, they want to find the second derivative at negative 1, 1, which means you do not have to take this and plug it in for dy dx to make it look like it's pretty with just x's and y's. But we do need to plug in negative 1, 1 everywhere. We might as well start by plugging in negative 1, 1 into dy dx. So I have 1 over 3 minus negative 1. I already did that, right? Negative 1, 1. So I already found that it was 1/4. So this is 1/4. Okay, 3 times 1 minus negative 1. So that's going to be 4. Minus 6 times 1 times the fourth minus 1 times 1 over 3 times 1 squared minus negative 1 squared. Leave it! Holy cow, leave it. This is acceptable. They have to accept this. Don't stress yourself out about doing arithmetic. Leave it. I know you won't feel comfortable doing it, but do it. You wanted to simplify. 4 times a fourth is 1. This is 6 fourths, which is 3 halves, minus 1, which would be 1 half, over 16. This is 1 half over 16, which is 1/32. Let's look at 2015 scoring guidelines. Number 4. No, number 6. Derivative, 1/4, 1 point. Equation for the tangent line, boom. You don't have to solve for y. This is fine. Vertical tangent, setting 3y squared minus x equal to 0 with 1 point. So just having this is worth 1 point. Getting your equation into one variable, which means taking this and plugging it in, worth 1 point. Finding your coordinates, 3, -1, 1 point. Taking the derivative correctly, plugging in 1/4, getting your answer. This is your answer. This is fine. But they simplified to get 1/32, just like I did. That was worth 4 points. 2 points for the implicit derivative. 1 point for understanding that you need dy dx at -1, 1. Easy. You know, differential equations can be easy points on the AP calculus exam. 2013, number 6. It's a good one. 2 parts. That's it. This is probably 3. This is probably 6. Whew. Write the equation for the line tangent of the graph of f at 1, 0. Use the tangent line to approximate f of 1.2. Okay, y minus y1 equals some slope, x minus x1. Y minus 0 equals some slope, x minus 1. What's dy dx at 1, 0? E to the 0, 3 minus 6. Because I'm plugging in 1. That's 1. This is -3. Approximate f of 1.2. -3. 1.2 minus 1. Done. You're done. You're done. That's fine. -3 times 0.2. You're done. Sure. You're done. Write this as 1/5 and writing this as -3/5. You're done. Multiplying this and understanding this is -0.6. Whatever. Who cares? Leave it like this. Leave it like that. I don't care. All right, part B. Let's solve. Solve the differential equation. All right. We got to separate our variables. Divide by e to the y. Multiply by dx. Take the antiderivative. Everybody's going to mess up on the left side, but you can still earn a lot of points. Just keep going. Y. A lot of people think the antiderivative is log e to the y. No, it's not. Because you rewrite this as e to the -y, and the antiderivative is actually e to the -y times -1. Over here, it's just x cubed minus 3x squared. Don't forget your plus c. You got the point 1, 0. Probably easy to plug in 1, 0 now. It doesn't have a log, so we're good. So I get -e to the 0 equals 1 minus 3 plus c. -1 equals -2 plus c. C is equal to 1. So this is -e to the -y equals x cubed minus 3x squared plus 1. Take the opposite of everything. Got to get rid of the e. Take the natural log of both sides, the entire t of both sides. That becomes -y equals log of, you don't need an absolute, and then take the opposite of both sides. Boom. That's it. Sometimes I ask you silly questions about domain. Nobody gets it right. Don't worry about it. Just get the solution. You'll get the points. It's easy. So this is 2013, number 6. Three, then 6. Incredible. 3 points for just getting negative 0.6. Uh, your tangent slope, your tangent equation, your approximation, which is this. This is fine. This is simplified. Separating your variables, 1 point. Antiderivatives, 1 point for each. Using a plus C, 1 point just for using it. Using our initial condition to find C, 1 point. Solving for Y, negative log negative x cubed plus 3x squared minus 1. And now look, they're saying like, oh, note, this solution is valid on an interval containing x equals 1 for which this is greater than 0. That's like a domain question that they're starting to, they got strict about at some point. But it doesn't matter. They don't ask that. You don't need this. Okay. 2012, number 4, last one. Number 5. Good question. Great question. Glad we're leaving off this question. I'll probably do this on class 2. All right. 3 parts. We have the rate at which a baby bird gains weight. It's in B's. B is the Y. T is the X. Okay, so this B is a Y. Is the bird gaining weight faster when it's 40 grams or 70 grams? Explain your reasoning. Well, let's think about it. B is the weight of the bird. dB/dt would be the rate of change of the weight. So dB/dt is the derivative of the weight. So it's telling us how quickly the bird is gaining weight. We just need to compare dB/dt values. What's dB/dt at B equals 40? I got 1/5 times 60. And dB/dt when B is 70 is 1/5 times 30. This wins. You'd say when B is 40, Y dB/dt at B equals 40 is greater than dB/dt when B is 70. Okay? Find the second derivative. Use the second derivative to explain why B cannot example this graph. Okay. Be careful. For taking a derivative of a derivative, it is helpful if you distribute. Now, it's not helpful to distribute when we're solving, but right now this is helpful. Because when I take the derivative of this with respect to t, I get d squared b over dt squared equals. This is gone. I don't just get negative 1/5. This is like a y. I need a dy dx. I need negative 1/5 times db dt. And guess what? I need this in terms of b. I can't leave this. I'm going to have to take dB dt and replace it with what it's equal to. Now, we're looking at b's between 20 and 100. Between 20 and 100, this has got to be positive, which means the second derivative is negative. Now, you might have gotten the second derivative as negative just if you took the derivative and you got that negative 1/5, but you are lucky. You need this dB dt. Okay, since the second derivative is negative, B must be concave down everywhere. This graph is not. That's it. Okay? Use separation of variables, they're helping you out, to find the solution to this differential equation. Okay, the distributed is not good for this part. This is not going to help you. Keep it factored. I need to divide the 100 minus b, leave the 1/5. So I have 1 over 100 minus b. Leave the dB, multiply by the dt, and I get that. I like doing this one because when we take the antiderivative, we need a log. This is 100 minus b to the negative first. You can't use the power rule, but watch why I also like this. That negative, that's a coefficient of b. I need the reciprocal. Many people forget that. This should be a dt, not t. Don't take antiderivatives until you're ready to take the antiderivative. But the antiderivative of 1/5 is 1/5 t. Don't forget the plus c. Now, I like to solve for b first before I plug in 0 to 20. I like to get rid of logs first. It will make things a lot easier. So let's take the opposite of both sides. I don't have to worry about doing it to the plus c. Let's take e to the power of both sides, understanding that this becomes e to the negative 1/5 t times e to the c, which becomes c e to the negative 1/5 t. This is 100 minus b. Now, this is a good point to plug in 0, 20. I get 80 equals c e to the 0. So c is 80, giving me 100 minus b equals 80 e to the negative 1/5 t. Subtract 100, divide by negative 1. So negative b equals 80 e to the negative 1/5 t minus 100 times the negative 1. b equals negative 80 e to the negative 1/5 t plus 100. Okay, let's see how we did. 2012, number 6. Sorry, number 5. Okay, comparing dB/dt at 40 and 70. dB/dt at 40 is greater than dB/dt at 70. Exactly what I said, 2 points. Getting the second derivative correctly, where you have negative 1/5 dB/dt. We get that. The second derivative is negative. B is concave down. A portion of the graph is concave up. Separating your variables like we did, 1 point. Antiderivatives, including this negative in front of the log, that's worth 1 point. Using a plus c is worth 1 point. Finding what c is by using the initial condition, they got rid of the absolute value, whatever. Who cares about this step? We just get rid of the absolute value when we find c. Finding c is 80. They did it at a different step than I did, whatever. Solving for b correctly. Boom. And they incorporate this. You don't have to worry about that. 5 points, man. Okay, differential equations. There for the taking. Just be ready. And we are done with differential equations. 2012. Number 5. All right, cool. One last video to make.